Oh, I don't think people are coming up. Maybe.
Yeah. Do you want to do like an A/B test, share screen or something?
Yeah.
Let me see.
Can you see my screen?
I can, yes, I can.
Yeah.
Yeah. Yeah, with Zoom is like, I think that way fairly reliable.
Yeah.
I had a lot of friction yesterday with Google Meet. Okay, let's give a few minutes. And just in case like people don't come up today, then what we can do is just push it by a week or something. Do a little more, like tweeting and, uh, what is it called? Social media, whatever it is.
Yeah.
And then we can do it again. I think it's
Yeah.
better with that way. Because I don't want to waste your efforts.
No, it's okay. Like we can just but you are not available today also. So yeah, we can just record and maybe
No, I
just
mean, honestly, like I'm not that important for the meetup like you are. And the fact that obviously you're taking efforts, they mean a lot. I just posted it on our internal Slack. I think a bunch of folks from my team are definitely interested. Sharath joined, so I know. That's how I got reminded. Hey, Sharath.
Hey, hi.
All right, let's eventually let's maybe another 5 minutes, and then I
yeah.
think after that, then let's start.
Yeah, quite folks I joined. Yeah.
Okay. All right, I think let's get started.
Yeah. So do we have like buffer time for introducing or
Yeah, let
like
me do like a quick, I'll just do a quick intro. Like, hey, everyone, welcome to PWL Bangalore. As you know, by now we're reading, developing verified programs with Daphne, and Devanshu is going to go through the paper, present his findings. It's a small paper. I think we'll probably be done in a short time. There are actually two papers with Daphne. One is the introducing Daphne paper by Microsoft, goes into depth about the language, and then this one, which is an easier introduction, where you just go through a bunch of examples. Like the idea is that you develop a verified program using Daphne. It has a, other than being a general purpose language, it runs static verification, and fundamentally addresses the question that, hey, whatever program you're writing, is it going to work as you expect, right? Which is actually, if you think about it, it's a pretty difficult problem to solve without some kind of static tooling, right? Tests and higher kind of types only do so much. uh, yeah, the whole angle of static verification, meta language, etc. There's a lot of programming languages research behind that. Daphne is just sort of like an introduction to that, and I'll let Devanshu go in depth on that. But yeah, I think let's get started. Over to you, Devanshu.
yeah.
Do you
Hello
want to
everyone.
do you want to give a brief intro about yourself? Like, what do you do? Maybe like, uh, you know.
Yeah. Hello everyone. I'm Divyansh Ranjan. I've been working on or like experimenting with functional language and proof verification for a long time, maybe 2 3 years. And but currently at I work at Google, and currently at work I don't use any of these languages. Just a side thing I do. So I've been experimenting with Daphne for quite a few times. Like I have tried to experiment with Daphne for quite a few times, but for last 1 year I have really started liking the language and trying to prove few things with Daphne. Before that, I have also experimented with Cog and Arda, and so those are also verification language. Or so okay, so and this paper we were talking about is developing verified programs. It is written by Tristan, who also developed the Daphne, and yeah. So I choose this paper because this paper is very easy in the sense that it's kind of introduction to programming in Daphne without, but it is in paper form. So that's why I chose it. So so before going and deep dive into the paper itself, I will say something about verification or theorem proving. Even though you are not proving things in your day job, but like these kind of concepts are very helpful for software developer. For example, reasoning about programs is it's one of the first time in the paper is that reasoning about programs is a fundamental skill which every software developer needs. And this is needed because sometimes you come across certain kind of bugs, and whenever you are debugging that bug, you kind of reason about program, but you're not doing formally. You are doing on paper or pen, or you are doing mentally. So you are doing reasoning about programs. And second thing, reading about these things is helpful because this gives you a list of words or vocabulary, so that you can communicate your idea. For example, like if you read about literature, you know what invariant means, what precondition means, what post condition means, and those kind of things. So even though you don't use in a day job, it's helpful skill to have. And yeah, and okay, so now we will do this verification or reasoning about programs in Daphne. And Daphne is mostly imperative language, but it also have constructs for functional and also object oriented. So and good thing about Daphne is that the barrier to entry for to Daphne is less than other proof assistant kind of thing. For example, Agda or Pub. So it's very easy to pick up with Daphne if you don't have any experience with if you don't want to read about theories and stuff like that, and you just want to play around and you want to prove your imperative or objective-oriented program. So that's why it is very easy to pick up. And one more thing is that which I did not mention is that Daphne is also type language, so you have to explain like this construct is type, and also besides these functional, object oriented, and imperative, it also, since Daphne is a verifier, you can have construct like this method needs some preconditions, and that and this method returns some post maintains that post condition. So whatever behavior you want program to have, you can specify it. So since this paper is almost like a introduction to programming, I will just jump into the editor and will show you the first program which this paper mentions. So so let's jump straight into the editor. So first program the paper mentioned is that you want to have a method which stores 3 integers, and just like every other language, Daphne has a concept called method, where you want to declare function. And since Daphne is type language, you have to provide every input and output parameters as a type. So let's say it takes 3 parameter as 3 integer as a input, and it also returns 3 integer as an output. And what we want to do here is that this construct is like you can find in every language. For example, this is a normal method which takes 3 integer and returns 3 integer. And what we want to do is that we want to return ABC, but we wanted to return in sorted order. And in Daphne, as you can see, the method return type are named. So, like for example, like there are three returns, three integers which are returned, and both like three integers are named. For example, they are named X, Y, Z here. So what we want to do is that we wanted to return ABC, but we want it to be like sorted. So so first thing we do is that we just assign these integers to ABC, and then we do some comparison and try to like return those values which is assigned to them. So like one thing you can do is that you can check that whether Y is greater than Z or not. So you can just if that's the case, then you can just swap those values, right? And you can do the same thing for X and Y also. And maybe you think that this is right. You think that this will return sorted ABC in sorted order in XYZ pair. And since Daphne is verified and it has other construct which you can provide that your specification is says that whatever your input is, the output is sorted order of that input. So you can just so in Daphne, the way you say that that this is the post condition of the method, that method returns that post like maintains that post condition is using ensures which you provide after returns. And here I wanted to say that X is like this is the sort order which I want to provide. But now you can see that Daphne is complaining that it can verify that whatever I have method in my mind is not correct, because it is saying that even though X is less than Y is not less than Z. And so it's saying that like your implementation is wrong in the sense that one of the post condition is not maintained. So we can ask Daphne what it knows about our method at this point. So it does knows about that X is less than Z and like X is less than Y. But like if I ask Daphne, does it know about Y is less than Z? I think it's erroring out. So like if you think about it, you understand that we are one comparison short, so you need one more comparison to swap Y and Z, because after swapping between X and Y can also greater than Z. So we need one more check, and then we can just a second. And then we swap the thing. Now it is saying that your implementation is correct. It is saying that you are returning XYZ, but and the X is less than Y and Y is less than Z. That's what we wanted. But there is one problem with this thing is that I can just say that X, Y, Z is this, and I can just delete these things. And this also verifies because our post condition is right, and there is nothing in our specification which says that whatever I am returning is permutations of the whatever I am getting. So our post condition is like our post condition is not strong enough. So we make that our post condition is more strong that our input set is same as our output set. So this is how how working with Daphne looks like, and this is how you define method, and like how the syntax of Daphne look like. And in the beginning, I mentioned that Daphne has concept of like return type has name. That you can see why the return type are named, because you need to refer to those names when you are giving the post conditions. And And one more thing I want to mention here is that we don't explicitly return in Daphne, like when conditions goes to the end of the statement, like method statement, it just whatever the values are there in the output param, it is returned. But you can, if you want to return, you can just write return XYZ, but that's also fine. But in Daphne, generally, people don't return, just don't write explicit return. They just assign to value whatever the return parameter is, and then when the control reaches the end of the method, it just returns. So this is the general flavor of like how the method definitions and how we can do like small like function verification in Daphne. If there's questions, like I think I can take questions right now. So
perhaps we can if look at like a slightly more complex example or something.
Yeah. So I will go through the examples, like slightly complex example like later, but like let me go back to the paper and see like something the paper like something which is mentioned in the paper is something which I missed or not. So yeah, so Daphne goes through all the parts, like there are multiple branches in this method, and Daphne goes through all the branches and see that whether in all those branches the post condition is verified or not. So, and as you can see, the Daphne verifier runs in background, and it gives you like a nice feedback loop, like these things are right and these things are wrong. And yeah, and ensures is how you can provide a post conditions to the method. And like before going like diving into the further into paper, I also want to spend like more example so that you can have a little bit idea about how Daphne works internally. Let's say you are writing a method, let's say call it A, and let's say, so in Daphne, so this in source is how you provide a post condition to your method. Like for example, what is the conditions between the return parameter and input parameter which holds after method returns, and requires is how you say that this function is allowed to call only when these conditions holds. For example, I can say that like you are allowed to only call this method when A is greater than 10. So this is how you do it in Daphne. And since I want to return something, let's call this returns, and I wanted to return an integer which is named B here. And let's say I assign 2 times A. Okay. Just retrace it. Okay. And now I wanted to ensure that B is also greater than 10, right? So this verifies, but like I'm giving this example because I wanted to show like how Daphne works internally, and like what is the like give you a small idea of like how Daphne works internally. So let's say here Daphne needs to verify that B is less than 10, right? And since this is a internal, like this is the like assignment expression, you can just swap B with A, and here Daphne need to verify that 2 times A is greater than 10. The process of like taking verifications, like going to the end of method and going step by step to the preconditions and calculating this Boolean expressions which need to verify is something called weakest preconditions. Like the process, like this is, so here I wanted to say that B is greater than 10, and for this I have to prove that before this assignment 2 times A was greater than 10. So here I am converting some conditions to some preconditions, and this precondition I am asking is weakest in the sense that it encompasses more program state. For example, if A is 20 here also, then our program verifies. But a is equal to 20 kind of like small our program state, so that it's not weakest preconditions, but 2 into a greater than 20 is kind of weakest preconditions, in the sense that we are asking like smallest constraint on the program state, so that our program kind of verifies. And then we are given that a is greater than 10, and then we have to prove that 2 times a is so this is something Daphne tried to prove. And the way Daphne tries to prove is that since this kind of like formulas are kind of first order logic, and it converts this logical formulas to Z3 formulas, and it offhands that formula to Z3 solver. And like if Z3 solver says that this is true in general, then Daphne verifies this program. So this is like general idea, like how. So this is like I give a statement, like give an example when the only statement it has is assignment. So these kind of taking a condition and like what's condition before that condition should be, so that our condition verifies, is called weakest preconditions, and it does for all kind of statements, like for if, for while loop, for all these kind of things. It builds those preconditions up to it hits the start of the method, and then when it hits the start of methods, it has some kind of a start of method has some kind of preconditions, and it verifies that after taking those preconditions into hand, those conditions which we arrived at the beginning of method is valid or not. So I can take any further questions here if something is not clear or stuff like that.
If anybody has questions, like just drop them in the chat. I'll summarize and ask Divanshu, or feel free to like unmute and speak up yourself. We're a pretty small crowd today, so unmuting and speaking should be okay. If not, I think Divanshu, let's continue.
Yeah. Okay. So this is the like generally in program we write method, and we want to verify these methods, and we saw that requires an install is how you do it in the general in method. But since Daphne is written for like imperative kind of programming in mind, it needs to verify the loops also, and for verifying the loop, there are various ways in which various tools and various verifier tools does these things. One way is that some verifier does like loop unrolling. For example, they will like try to see that what if loops run 0 times, and if loops run 0 times, things verify or not. What if loops 1 times, and they do unrolling up to fixed number of times and see that programs verify or not. This is one way of doing it, and but Daphne uses a different way to like verify loops. And in Daphne, you have to provide something called loop invariant to proof loops. And in the first case, you don't have to like in loop rolling unrolling, you don't have to provide an invariant, because after you unroll the loop, like it will be either a statement or if statement or stuff like that, and the verifier knows how to calculate the weakest preconditions from those things, and it doesn't need any extra help. But in Daphne case, Daphne needs and help, in the sense that Daphne need you to like provide some summary of the loop, so that something which doesn't change in the loop, and so that it can verify. I think it's better I switch back to my editor and show you like how things work in Daphne, and give you example, and like give you running example, and give you like live demo of like how it does in like how it looks like in Daphne. So I'm picking only those examples which is mentioned in the paper, but like if people want, I can also give like other examples.
Hey, Divanshu, if you take a few minutes pause here, There is a question on YouTube, I think, is which is useful for the whole audience. Is that what kind of problems are we trying to solve with Daphne? Uh, I think what the asker is trying to get to is like, what does verification bring, and what are some use cases? Where is it used, etc. Do you want to spend before we dive into an actual program?
Yeah.
Uh, uh, would
Yeah.
you
So
take a few minutes to talk about that?
yeah. So okay. Let me bring this. Okay. Okay. Just it. So like for example, let's say this program. Like there are various ways you can say that you when you write some program, you have some specification in your mind. Like for example, this program does something. Like you write program for doing something, and how you verify that the program does what you intended it to do. One way is that you can write tests, and test is like easiest way to do that. And but if, like if your method you're writing is very complicated and it has lots of branching and stuff like that, you have to write lots of tests, and you also not sure like you cover all things in your test or not, right? Um, so like what verification brings is that it kind of it kind of gives you a tool so that you can it gives you a language so that you can write in a programming language what your specification is. So generally, like people write in like other language, they will write in comment like this program does that, or maybe like in some language, then they are concept of asserts. So you can just say that at this point of program, this thing should hold. Otherwise, I will just fail out. But that's done in the runtime in most cases. And but yeah, so like one thing it gives you that it gives you a like a language to write your specification, and other thing is that it also tests like your specifications hold for all the parts. Like testing is one way to do it, and a specification is the another way to do it. So yeah, that if I don't know whether that's answered the questions.
Yeah, I think it does. And to add on to that, like honestly, there are many ways of verifying the correctness of a program, and the most popular way is writing tests, but it's often not enough, right? And the idea is that there are more advanced and far better mathematically proven ways of doing things, and this style of writing program is one of those disciplines. And so if you think about it from that perspective, the applications are as such limitless. There is no specific use case built for Daphne that okay, only write these kind of programs. Anything as long as language paradigm, everything allows, can be used for
May I
anything.
ask something if you guys can hear me?
Yes, we can hear you
Perfect.
now. Yep.
This is Dilawar. I write kernel drivers once in a while, Windows kernel drivers, and Microsoft gives you a verifier which runs in the background and make sure that your driver is not doing something silly with the memory, right? And once in a while, I would like to use these kind of tricks inside the C program or C++ program which we are writing, right? So the part that your verification is also part of the program is very enticing in Daphne, because the previous couple of things I try to look at binary distant diagrams, I think BDD based, other LTT, something which I don't understand it very well, but they were all like you have to write a wrapper around your program or try to describe the properties you want to solve first. So I have two questions here. Is that from the development perspective, can you disable the verifier once you are confident, okay, fine, my program works fine? So your binary which goes out in the production does not have that verification layer. So probably it works faster, efficient, consume less memory. And second is, if we just look at the existing these tools or these verification, for instance, one of the language, I forgot its name, is very popular by this very famous computer scientist. If I recall the name, I'll say it. He also has this language for formal verification. I mean, if you compare and contrast, is it as powerful as any other, or is there some disadvantage or advantage? Probably that will also help people who are using such tools.
Okay. Yeah. So So for answering the first questions, whether these asserts or ensures run on the like these checks are run on the runtime, no. So these checks are static verification. So like whenever like Daphne, generally using Daphne you can split out code in like few languages. Python is one, Java and Go is also supported. So when Daphne splits out like if you write a program in Daphne and you want to split out program in those languages, Daphne removes all these asserts or post conditions and preconditions. Daphne verifies these things statically, so that's one thing. And every for answering second questions, every form verification tool has some kind of limits, and like some things might easy to do in some language, some things are hard to do in some language. For Daphne, in general, I think I picked up Daphne because it's very easy to demo for software engineers. But like in general, you can do like everything in Daphne which other tools do. For example, like as far as I know, the one of the earliest formal verifications of the Paxos was done in Daphne from by Iron Cloud people from Microsoft. So yeah, I think yeah. If I don't know whether that's you have further questions or you want to expand.
Yeah. So I'm not sure how much time I can take, but I have one additional point actually, just to probably highlight the issue which I'm trying to get. So as an electrical engineer, you are once in a while you are interested in those liveliness properties of the state machine, that eventually this will happen, or it never happens, or it happens after certain number of steps, right? So what I'm not getting at looking at this method, that the time, how the time is encoded, that this is all of this is true when the function is called, or this also keep track of that eventually sometimes this is violated, and only time you get how shall I say, the proof of the violation, or it's something theorem proving kind of thing, that without running the program I can say something like eventually this will happen or it will never happen, so on and so forth.
Yeah, so like this don't have concept of time in the sense that it just takes parameters and it spit out the parameter. But to answer your questions, if you wanted to prove liveness property with Daphne, it's possible. I will point to your paper. Like this paper is called Modeling Concurrency in Daphne. It is written by Rustalino, and it gives you example like how you want to encode liveness property in Daphne. So it's a very nice paper. If you want to prove like liveness property in Daphne, you can do it.
That is helpful. Thank you.
Yeah. Yeah. So okay. If there is no more question, I can just give an example of like how loop environment, like loop, like how you verify loops in Daphne. So this is we will write a small function which calculates the triangle number. Triangle number is like for n, it is sum of number up to n. For example, 1 is 1, 2 up to 3. Like for 2 it will be 3, and for 3 it will be 6, kind of thing. So like there is a closed formula for that triangle number, and you can also write a loop which just sums the number. So just, and then we will add verification and see how Daphne reacts and what information Daphne gives. So let's write a triangle number I want to write, and then let's assign it to 0, and then let's have a loop and like loop variable which will go to n. And what I want to do inside loop is that I can just and then do this thing. Okay, this looks right. Like since there is no like no verification in this method, Daphne just is fine here. But like even though there is no loop, Daphne does checks that your loop is not infinite loop. For example, if you do this, it will complain that Daphne cannot check, like Daphne cannot verify that whatever loop you have written is not like it will finish. So like without any specification, Daphne checks one thing, that your loop is kind of like there are fixed number of iterations your loop does. So this is one thing I want to mention, and then let's write some preconditions. One first precondition I want to write is that whatever I'm calculating, like since this is a triangle number, we know that it has some fixed closed formula. Okay. So if you write this thing, it's like Daphne doesn't complain that it cannot verify because just the paper mentions for to reason about a loop in Daphne, you have to provide a loop invariant, and the way you do is that you write invariant and then okay. So let me tell something about invariant. Invariant is something like you want to like invariant is something even though you write loop for you write loop to change something you assign to some variables or like loop in like a loop index is always changing, but like even though in loop things are changing, there is something which are kind of unchanged in every loop iteration, and those properties kind of specify what loop does. And here one thing to mention is that even though I is changing, the current value of t is triangle number up to I, so we can provide that. So let's write that. Okay. Like even though you write Daphne is not able to verify it, let's see. Okay. Yeah. Even though, because let's ask Daphne what it knows about this point. So one thing you can add additional assert. So one thing Daphne knows that loop finished. So it knows that I is certainly greater than equal to n, right? Right, and I think it also knows whatever value of I is it is equal to t. What it doesn't know is that I is exactly equal to n. So you have to also, like, for example, since you can also like it not like you can also increment by 2. So like it is not always the case that whatever the loop conditions you provide, the variable will always after the end of the loop will be the same as the whatever the conditions you have provided. For example, if your n is like 5 and you're starting with 0 and you incrementing by 2, then like after end of loop I will be 6. So those kind of things, because of those kind of reasoning, it doesn't say that after end of the loop, Daphne knows that I is equal to n. It knows that I is greater than equal to n, but it doesn't know that it is equal to equal to n. So you have to provide one more invariant to Daphne that whatever the value of I is, it is between 0 to n. Okay, what did I miss? Okay, now it's saying that again this invariant doesn't hold, because like invariants should also hold when the first time it enters into a loop. And what happens if I call this method with a negative number? In that case, I am assigning I to 0, and then at the start of the loop, it's not possible that I is greater than some minus 10. So you have to add some precondition to this method. Like I want to provide some. Just a second, I forgot how to provide requires. I forgot the keyword for providing the environment. So I have to say that whatever I'm doing, like this method will always call when n is greater than 0. Now Daphne verifies everything, and this is how experience of verifying loop in Daphne looks like. So when providing a loop and invariant, you have to think about like what I wanted to prove our program after writing the loop, and whatever the invariant I am providing was sufficient enough to prove those things. So this is how I think about, like, when I'm writing loop invariant in Daphne. There might be other way to think about it, but I think yeah, that's how I do it. What I wanted to prove about after loop ends, and how strong loop invariant I should provide so that it can prove that thing. So if any questions about how loop invariants or other things till now, I'm happy to take any further questions right now.
Yeah, so I think Sudhar is asking that it should not be able to prove whether the loop exits. It's not it's technically not the same as halting problem, but because loops are deterministic. But I'll let Devanshu address that.
Yeah, so in Daphne loops you cannot do all kind of computation, you can if you write some kind of program which kind of imports halting problem, Daphne will complain it, and there's no way for you to prove it because this is the because of the halting theorem. So yeah, because it's you cannot prove it. You might write it in Daphne, but you cannot prove it that it will exist. So you have to what you have to do is that if you wanted to write those loops where you say that I don't know whether this loop by default Daphne assumes that whatever you are writing is finite computation. But if you wanted to do something like you don't care about loop exists or not, whatever you provide decreases and you should say a star. I don't care about this loop exists or not. So yeah, that is one way to do it.
But shouldn't we add the, so let's say if we are changing a variable value within the loop,
yes,
is it necessary? I mean, will it automatically figure out that we are changing the variable's value, or should we definitely add that to the invariant list in the top? Yeah.
So for proving termination, it doesn't need invariant. So it is able to prove that that this program exists, this loop finishes, but I need this invariant to prove this statement, that after loop exists, then I need this loop invariant to prove these things, because using this and this, I can say that after loop finishes, I is exactly equal to n. But loop invariant is not prepared for proving termination in this case.
Okay.
Okay. Okay, let's go back to the paper and see if I missed some points which I wanted to mention. Yeah. Yeah, so the way to think about this loops is that when verifier checks region about the loop, it doesn't, after loop finishes, it doesn't look into the loop body. It only reasons about loop whatever based on what invariants you provided. So so you have to be very careful about what property you want to use after loop finishes. So you provide that as a part of invariant. Okay. So next thing I wanted to mention is that since Daphne has all these different way to writing programs, it also has provides mathematical functions. So you can write pure functions in Daphne, and there is some culture involves how you write functions in Daphne, and in general where we are writing statements when you are writing methods, but when you write functions, you have to provide expressions, and syntax of functions are little different than method, and functions are given so since functions are expressions, you can use them as a part of like your verification conditions. You can call functions in your inserts and requires clause. You can call functions on your invariant clause. So yeah. So before going further, let's give the example. Like let's go to the example which the paper provides, and let me give you a test of how it looks like in Daphne. So this is let's say you want to write a function which calculates power of 2, and just like a method, it like you provide a input parameter and the input type, but since it is expression, and in the function you can only return one kind of, like you cannot return multiple output expressions. So you provide whatever the output type is with semicolon and colon and with output type. And in method body, you provide your expression. It's expression, not a statement. It's a tricky thing. I also do that mistake sometimes. I write a statement in the function instead of like writing expression. So let's write what it looks like here. Okay. So this is how it looks like, and Daphne like already confirmed that this is it is not able to terminate. So you have to provide like a requires clause that you're calling it with n is equal to 0. So this is how you write. Notice that I haven't terminated this statement like statement with the semicolon. So it's expression. So that's the only point I want to mention. And so this is we will see like how we can use functions in Daphne. Okay, let me give you an example like how to use this function in verification, and how it is later in the paper, but let's dive right into it. So this is calculating the power of 2, and there is like a efficient way to calculate power of 2. Like one is called successive squaring, where for like currently the complexity of this method is n, but successive squaring does the computation in log n. So you want to implement that method, and you want to show that whatever this is calculating is the same as the successive squaring is computing. So let's just write this down. And just like our function, it also requires that n is greater than 0, and since it's a function, I have to provide what I'm trying to return here, and we will add the post condition and a specification later after we write simple logic. So this is how you can successively square things and calculate in log n square. So if n is equal to 0, you can just say that p is equal to 1, right? And else n is, then what you want to do is that you can just say that compute power n by 2 and p is equal to like you want to multiply t 2 times so that it is square. Else what you do is that you say -1, and then you say p is right. So this is like a way to do it, like successive squaring. It's calculating in log n square. You can see that it is log n. For example, it's halving the n in every call, and since we are using Daphne, you can say that inserts, let's say whatever P is returning is power of n. Now, Daphne complains about it because it's very tricky to prove, like it's very tricky to prove. You have to provide some help to Daphne to prove it, and let's go through it. So, for example, here you can say that you can tell that things like asserts power to 0 is equal to 1. So, and since p is equal to 1, both are equal, and this condition holds. So Daphne is not complaining about this doesn't verify in this branch. It doesn't also like error out in this branch also, because it knows that t is equal to power 2 n minus 1, and your p is equal to 2 times t, and you are calculating 1 up, so you are multiplying by 2. Here it's tricky in the sense that for proving things like this, you need some kind of induction, so that induction and some kind of you actually need some kind of induction, so that Daphne knows about those things. So one way to do these things in Daphne is provide a lemma. For example, you wanted to prove things like, for example, when n is equal to, like, for example, here Daphne knows that, for example, Daphne knows that assert t is equal to power. What it doesn't know is that, like, for example, power to n by 2 into power 2 is equal to power 2n. So these things doesn't know, but it knows these things. So so you have to prove these things explicitly, and after you prove those things, you can just use those lemma or methods here. I will show you how to do it. So that you guys are clear, like where Daphne is not able to figure out and where which things Daphne knows. So one thing we wanted to have is that we like. Okay, so let me talk about something called lemma. Like I have started talking about these stuff earlier. This is mentioned in the paper in the end. I think it's since I'm talking about functions and compute power and lemma are mentioned in the end, and they uses this function definition. So I think it's easy to do it in a single go. So lemma is something which is kind of method, but here everything is kind of a specification. You don't like you don't write a code which will run. It's just used for verification, and by verification I mean like you wanted to prove something which will be later used for proving like this method. So what do you want to prove here is that I'm using, okay, let's use this thing, and since lemma is kind of method, it has all those things like you can have require and insert kind of thing. So let's write this. This is a require, and what we want to ensure is that in lemma is that okay, and we only want to prove these things for when and we also only want to prove this lemma when n is an even number, and what we want to prove is that when n is even number, this holds true, right? And like okay, let me see where this Daphne is erring out. Okay, it's saying that I have used the same name. Okay, now this lemma I have written it, but Daphne is still not able to verify it because it is facing the same problem which it was facing here. But like when you write proof in Daphne, you write this lemma and see if this lemma helps or not. Even though you haven't proved this lemma, let's call this lemma here and see that if our original methods verify or not. So let's see that if using this lemma solves our original problem, and it does. So I think this is the right lemma to prove, and we'll prove it. Like one way to do is that like check for n is equal to 0, Daphne is able to prove or not. It is able to prove. Only the like when n is greater than 0, it is not able to prove. So what we can say that since it is kind of like you wanted to like induction here, you can just say that like you can call induction hypothesis here, like for example, like prove these things for n minus 2, and Daphne very like. So I will go into more detail like why this is happening, and Daphne is doing lots of things in the background, which I will just explain, and why it is able to prove it. So let's say so here it is. You can see that it is able to prove because power to 0 is 1 and power 0 divided by 2 is 0. So it is able to prove. But here, what we wanted to prove is that assert power to n by 2 equal to power to n by 2. So here, what we saying that call this lemma for n minus 2. So here, Daphne knows that. Let's write this down. Daphne knows that now after calling this lemma, Daphne knows that power to n minus 2 divided by 2 and power to minus 2 divided by 2 So since I am calling this recursively, Daphne now knows that this is true, and Daphne now has to prove that. And Daphne, what Daphne does is that it does power n is equal to 2 into 2 into power n minus 2, and then it okay, I have missed these things. And what it does is that it splits out this equal sign, and then multiplies 2 to each part, and then like add the exponent and see that it is equal to n by 2. So this is how like internally Daphne does it. You can write these things explicitly if you want to, and there is a way to do it in Daphne in a nice way. I'm currently writing all asserts. There is a concept called call C, which is like you want to do calculation, this kind of proof calculation, and it will be very easy to look into. But like Daphne, like when you're writing the proof, it's like it's nice to do in this way, but like once you know how Daphne does internally, you can just remove these things, and you can provide minimum amount of information Daphne needs. So yeah, so this is how now you can see that here I have used the our functions in our specification. So since functions are a statement, and you can use a statement where any resource and required. So I will pause here for some questions and any comments.
Checking on YouTube really quick. Okay. At the moment, no questions.
So if you deal with the floating point numbers, how much of this is still there?
Oh, like depends on like how since Daphne offloads these queries to Z3 or SMT solver, so how much floating point theory those Z3 provides is what is supported by Daphne.
Okay, well, I don't know anything about the underlying engine, so.
Yeah, I can yeah. So like I give you like a short answer. Like for example, since this like in the earlier talk, I talk about weakest preconditions, and those preconditions are Boolean logic and first order logic, and those first order logics are you can solve it using empty solvers, which are very efficient in solving those kind of problems. And then on the top of those, they provide some kind of theories. For example, they know that addition is like order of addition doesn't matter when you're adding two numbers, and those kind of theories, they provide additional structure on the top of that. And so like they have inbuilt theories for floating point, and they might not support all the like mathematical theories which floating point provides, but they have some inner notions of those structure, and whatever they support, Daphne will support it.
So I'm guessing if you can construct a Boolean function, then or a truth table, then it's okay. Otherwise, you are not in luck. Is that right?
Like your Boolean is not important here. Boolean is in a sense that like for example Boolean is not important in the sense that it is like whatever you can encode in first order logic should be enough. It can support, Daphne can support, and Z3 can support.
I think Swanand shared the GitHub repo, so I think I need to read up a bit. Thanks.
Yeah.
Yeah. Z3. I mean, just to expand on that, Z3 is an independent theorem prover from Microsoft. You can look into that. It has other layers. So is it integrated with the Daphne?
Yeah. So let me give you like a small overview like how Daphne works. So Daphne takes this syntax and converts to an intermediate language which is called Boogie, and then Boogie converts those statements into the Z3, and I think I can show you right now. So like here, Daphne is converting these things into the Boogie. So this is the intermediate language. Like it has lots of all other Daphne constructs, and then you can convert these things into Z3. And yeah, let me see that. Yeah, it is a big file. So this is the like Z3 file which generated by Boogie. So, but like it's very not fun to look into because it has all the internal structure of Daphne inside it, and it's very hard to figure out where your difference is. So yeah. So this is the what the Daphne sends to the Z3. So yeah. I can take a few more questions and then we can just go to the paper.
Cool. Anyone else? I think on GitHub at the moment. Okay. Cool.
Yeah. So okay. Let me. Okay. So Daphne also has concept like Daphne has mismatch of like various programming paradigms. So like Daphne also has like you can provide data types in Daphne, and you can write functions over that data type, and then you can write like a specification on those data types. And here you can see that in Daphne there is a data type which is tree, and it has two constructors. If you think about constructor way, one is leaf and one is node, and it like you can write a simple functions over these kind of data type. And Daphne has a construct called match where you want to pattern match over these ways where to construct those things. And here they have written a functions which checks that whether T contains that value or not. And one more thing I want to point out that Daphne has like a type parameter where like you can like since node value can be any type, and Daphne has concept of type parameter, you can create any node type. And then they have written a small verification for fill method where you provide a tree and provide an array, and you provide a start method. and it will try to fill that array with 3 elements, starting with start array. And one thing to note here is that like whenever a method tries to modify heap allocated object, you have to provide something called modifies clause. So here you can see that array is one of pointer based reference, and Daphne has to say that Daphne has to provide in specification set that I wanted to modify this method. If you don't provide it, Daphne will error out, say that you are trying to modify but you haven't provided as a part of a specification that you want to modify that. And one more thing I wanted to point out is that all the post conditions and preconditions we have seen till now was kind of not it doesn't quantify over whole lot of lines, but you can do it using for all clause. So here what you want to say that when the field is called the array elements from start to end contains those in the tree, and also before start index you haven't modified anything into the array itself. So so if people want, I can just give example in the editor also, but if don't, people are bored seeing me typing on the editor, I can just skip that.
Nobody's bored. We can cover that. Up to you.
Yeah. Okay, okay, let me cover this example because this is the last example. And other example is the class one, which is very large. So I will skip that instead of this one. So one thing which paper mentions and which also I want to highlight is that our post conditions only say that array element after a start and up to end contains that tree element, but it doesn't say in which order it contains, and and other things you can say in general about this. So how strong you want to say about your specification is something which you have to decide, and also you have to pay a price in the sense that you have to prove more stronger things, and proving those things might be trickier than figuring out this straightforward thing that it just contains. So yeah, before going before jumping into the class example, let's go through this tree example. Let's see data type. Let's write tree, and then it has 2 constructors, one is tree and another is node, and then this is also tree. This value, this is tree, and then so this is how I have omitted the type parameter. You can omit here. You have to only provide in this in the data type itself. And let's write a simple function which checks whether your value is contained into the tree or not. Okay. Here I also have to provide a type parameter, and since this is a function, I have to provide a output type, and then this need to be an expression, not a statement. And this I am mentioning this thing because there are tricky cases in Daphne where it looks like you are writing valid expression, but valid expression, but that might be doing a different thing because you have preconception of how things written in the statement. So let's write in this case it is otherwise it is left 30, and to check that whether that value contains in the tree, we will check that whether this is the key is equal to value provided, or the left thing contains the key, or right thing contains the key. So this is like pattern matching. If people are familiar with pattern matching with other function language, it has pattern matching, and you have to provide the pattern, and then you have to provide various cases, and then these all expressions should be of the same type, which is the return type. Yeah, in this method we don't need any precondition, post conditions. Yeah, that's one thing I want to mention, that since this is a function, and Daphne, when Daphne reason about method, it only knows about post condition about that method when you call that method. But functions are visible to Daphne. Daphne can unroll the functions, and like since this is a statement, whenever this function is called, it can just like split out this code instead of like function and reason about the expression itself. And we will use this function to reason about method. What this method does is that it takes a tree and it takes an array, and array should be of same type, set type, and then it takes some int, and it returns another integer. And what I want this method to do is that it will fill array with elements of t starting from start, and it will return the last index where up to where it has written the array element. So this looks fine. We will just write like earlier methods that we will write without specification, and we'll try to add a specification and see how Daphne reacts and how we can help Daphne. So just like our function, our method will be the same structure where it will be matched, and then depending on different match cases, we will try to do things. So in this case, if we hit the leaf node, then we just say that we haven't filled anything, and our end is start, and our specification was that from a start up to end, excluding the end, whatever the element will fill in the array will be part of the tree. Let's write the other thing where we just okay. So here what we want to do is that like since our specification is very liberal, we can fill in either way, and the way paper mentions and the way I'm going to do is that I will just try to fill the array elements with the left tree, and then we'll try to fill if there is an element left, then we'll try to fill with V, and then try to fill with the right children of the tree. So let's do that. We will recursively call with left and then array, and then now if you want to check that like there is still something left, like there is a space left to fill. So right, and then we can fill that element with V, and then we can just say that fill the remaining elements with A, and since we have filled up to end, we have to put n+1. So this is free to read, and Daphne was already complaining that you are trying to modify, but you haven't provided any modifier clause. So you have to say that I want to modify A. So I want to say that this method modifies A, and what is complaining is that it is out of range because we know that an returns an int, but it can be any int. So this field can return something, let's say it returns a million and arrays of size 10. So you have to like say that whatever you are returning is between start to end of the array, right? Now it is complaining again because you haven't specified what start can can be. Like caller of this method can call start with like negative number. In that case, not negative number, maybe greater than length of array, and then in that case, this condition might also not hold. So here you can have add a require clause, whereas that caller can call only with a start up to 0 to array length. And these are the these are the specification in the sense that like we are not accessing any array out of bound, but like we want strong condition that whatever values we are returning are from the tree. So we have to add that thing. So this is how you write in Daphne that for like range of values you want to say something. So what I want to say that to start to end our tree contains the array element. So this is how to do it. Now the problem here is that contains. Now Daphne still not able to verify this thing. It is very hard to figure out from looking into this code base why it is unable to verify, but you can write various asserts to figure out what Daphne knows and what Daphne doesn't know. And the reason here is that here you are saying that between start to end, your array like whatever you are putting into array contains into tree, but you are not saying anything about other array elements. You are not saying that you will not modify those array elements. So you have to also specify that. For example, let's say one call might put that tree element into the array, but other element, like for example here I can add a clause that put random value into the array start, maybe array 0. So in that way, in that case, like for example here I can say that put some random value into the last element of the array, and in that case that random element may not be the part of it. So you have to provide something called like I don't want you want to provide something called that whatever I'm doing, I am not modifying any array element between 0 to start of the array. So this is you have to provide it as a part of post condition, and this is you do it. For example, let me explain this all part. All part means that whenever the method is called, what was the value of a, and after method returns what was the, so this a expression will use the value of a after like in the last statement, and this old a means that what was the value of a when the function was in before doing anything. So this is way to do it. I think still not able to verify. Let me see. Okay, this is saying that in this part it is okay because Okay, let me see why it's not able to verify. Let me first check that whether I have written this. Oh, I have written this. So I have written this contains wrong. I am checking like in left or right. The key is part of left or right or not, which is the like, and you can see that Daphne is able to figure this like this crazy problem itself. So I have to fix this thing. Yeah, now it verifies. Okay. Yeah. So this is how the like, since this paper is very static and working with Daphne is very lively experience. So I wanted to show like how it looks like. Like I think we are on the last part of the paper. So you can also specify the class in Daphne and like most of the things we have covered in till now. One thing you can do in Daphne is that you can also provide ghost words. Ghost word is something which are state you wanted to hold on for verification, but like these things these things are not required in runtime program. These are something which is required because you want like you want to hold on to some previous state and you want to compare it with the new state and there it might be like before function method call because like in method call you have construct called old. Those kind of things you can just use coursework, which is like you want to hold on to some state and you want to verify it. So that's the additional thing, and I think yeah, that's all. That's all I have to cover. Yeah.
Awesome, cool. Quick note about like any note about further reading and what
yeah, so I think Rustan has a like a YouTube channel, verification center. Like videos are like very old, I think, but he goes through few examples and there is a paper also, Daphne papers. But I think Rustan has also written a book which I just got just right now, and but that book is draft and. It's not, you cannot find it in Amazon. You have to there's a independent publisher called Lulu where there I think I can show you the book, and this book goes into detail about like I don't know whether you can see it or not. It is called program proof and it goes through like all the details. Yeah.
Okay, awesome. Great. I think a lot of people actually dropped off in the last 10 minutes. So let's stop here today.
Yeah.
I'll make the recording available and share on social media. Thank you so much, Devanshu, for covering this what I call as nerdy topic.
Yeah, thanks for having me. Yeah, it was like nice to talk to somebody, which I'm doing like in my own and like talking to myself. Yeah.
I think one question came on Twitter is that are there any well-known use cases or well-known production use cases for Daphne? Like, is anybody using it in production?
Yeah, Amazon is using lots of formal verification tool, and Rustan is currently working at Amazon, and I think in one of keynotes they have mentioned Daphne besides TA Plus and other things.
Nice. Yeah. I think that in usually meetups like that question always comes up, even for like arcane languages, that hey, is it for production? I'm not so big on that. Like I'm happy to just write Daphne code on Saturday and then write some Ruby code on Monday for production.
Yeah, one thing I also want to mention is that like Emacs is not required. I'm just using Emacs. I think easiest way to get started with using VS Code, and I think VS Code has very like it's beginner friendly. You can just use, and there is a Daphne plugin, and it will install Daphne itself. I think maybe you might need to install a .NET runtime, but that's extra thing you have to do. But otherwise, you are set to go.
Got it. Okay. Awesome. Well, great. I think that's a wrap for today.
Yeah.
I'm going to